Welcome back to Java Internals Crashcasts. I'm Sheila, and with me, as always, is Victor. Today we're diving into the fascinating world of wait and notify mechanisms in Java. This is the final section of our chapter on synchronization fundamentals, part of our season on the fundamentals of concurrency.
Hello everyone, I'm excited to explore this crucial aspect of Java concurrency with you all today.
Before we begin, listeners, make sure you're familiar with the concepts of threads, synchronization, and the synchronized keyword. We covered these in our previous episodes, so if you need a refresher, be sure to check those out. Now, let's kick things off with a quiz question. What's wrong with a simple piece of code that tries to wait for a signal without proper synchronization? Victor, would you like to break this down for our listeners?
Absolutely, Sheila. This is a great question to get our listeners thinking. Without giving away the answer, I'd say this scenario touches on some common misconceptions about using wait. It's a simple piece of code, but there's a crucial detail missing that could lead to some unexpected behavior. Listeners, pay close attention to how wait should be used and think about what we've discussed in previous episodes about synchronization.
Thanks, Victor. Now, let's start with the basics. Can you explain what wait and notify mechanisms are and why they're important in Java concurrency?
Certainly. Wait and notify mechanisms are fundamental tools for inter-thread communication in Java. They allow threads to coordinate their actions and efficiently wait for certain conditions to be met. Imagine a doctor's waiting room. Patients, threads, arrive and wait their turn. When the doctor, a resource or condition becomes available, they notify the next patient. This is essentially what wait and notify do in Java.
That's a great analogy, Victor. So how do we actually use these mechanisms in our code?
Good question. In Java, every object has wait, notify, and notify all methods inherited from the object class. These methods must be called within a synchronized context. Essentially, we use these methods within a synchronized block to manage thread communication.
I see. So when a thread calls wait, what exactly happens to it?
When a thread calls wait, it releases the lock on the object and enters a waiting state. It's like the thread is taking a nap in the waiting room. It remains in this state until another thread calls notify, or notify all on the same object. It's important to note that when the thread wakes up, it doesn't immediately start executing. Instead, it re-enters the blocked state, competing to reacquire the lock on the object, like trying to get the doctor's attention once they're available.
That's interesting. You mentioned notify and notify all. What's the difference between these two?
Great question. Notify wakes up a single thread that's waiting on the object. If multiple threads are waiting, one is chosen arbitrarily, like tapping one person on the shoulder in the waiting room. On the other hand, notify all wakes up all threads that are waiting on the object, like announcing to the entire waiting room that the doctor is ready. The choice between notify and notify all depends on your specific use case and can significantly impact the behavior and performance of your program.
I can see how that choice could be crucial. Now, let's talk about a real-world scenario. How might we use wait and notify to solve the classic producer-consumer problem?
The producer-consumer problem is a perfect example of where wait and notify shine. Imagine we have a bounded buffer. Producers add items to the buffer and consumers remove them. We need to ensure that producers wait when the buffer is full and consumers wait when it's empty. In our code, we'd use wait when the buffer is full for producers or empty for consumers, and notify or notify all when items are added or removed. This way, threads can efficiently coordinate their actions without constantly checking the buffer status.
That's a great example, Victor. Now, I've heard that there are some pitfalls to watch out for when using wait and notify. Could you elaborate on those?
Absolutely, Sheila. There are indeed some common pitfalls to be aware of. One of the most important is the risk of lost wake-ups. This can happen if a notify is called when no thread is waiting, and then a thread subsequently enters the wait state. To prevent this, we always use a while loop to check the condition, not an if statement. Another issue to be aware of is spurious wake-ups. This is when a thread wakes up from waiting without being notified. It's rare, but it can happen, which is another reason why we always use a while loop to recheck the condition after waking up.
Those are important points to remember. How do wait and notify compare to other synchronization mechanisms in Java, like lock and condition, from the java.util.concurrent package?
That's a great question. While wait and notify are fundamental and still widely used, the lock and condition interfaces provide more flexibility and fine-grained control. They allow for multiple wait sets per object, fair queuing, interruptible and timed waits, and non-block structured locking. However, they're also more complex to use correctly. In general, for simple scenarios, wait and notify are often sufficient and easier to understand. For more complex synchronization requirements, especially in highly concurrent applications, lock and condition might be more appropriate.
Thank you, Victor. That gives us a good perspective on where wait and notify fit in the broader context of Java concurrency. Now, before we wrap up, let's reveal the answer to our quiz question. Victor, would you like to do the honors?
Certainly. The issue with the scenario in our quiz is that it's not calling wait within a synchronized block. This is a common mistake and can lead to an illegal monitor state exception. The correct approach would be to use wait within a synchronized method or block and always check the condition in a while loop. This ensures proper synchronization and handles potential spurious wake-ups.
Excellent explanation, Victor. To summarize today's episode. 1. Wait and notify mechanisms are essential tools for inter-thread communication in Java. 2. They must be used within synchronized contexts. 3. Wait releases the lock and puts the thread in a waiting state. 4. Notify wakes up one waiting thread, while notify all wakes up all waiting threads. 5. Always use a while loop to check the condition when using wait. 6. Be aware of pitfalls like lost wake-ups and spurious wake-ups. In our next episode, we'll be starting a new chapter on locks and conditions, diving deeper into the java.util concurrent package. Don't forget to subscribe and leave us a rating if you're enjoying the series. Thanks for listening to Java Internals Crashcasts.